the second type of reaction, it is nucleophilic addition reaction. Nucleophilic addition reaction. You can abbreviate as a NAR. Nothing wrong to abbreviate if you have some information, smart starting letters, you can use it. But however, it is called as addition started by nucleophile. Therefore, the types of reactions, you have to code this reaction as a AN type of the reactions. With nucleophile reaction takes place. Example, all aldehydes and ketones undergo this reaction. Aldehydes and ketones undergo this reaction in addition to the cyanides and some acid derivatives and so on. But main reaction is aldehydes and ketones. As I said, what is the characteristic reaction of aldehydes and ketones? Nucleophilic addition. Or the nucleophilic addition is shown by which of the following compounds? The first example goes to the aldehydes and ketones. Together you can say carbonyl compounds. Okay, both the compounds together you can say carbonyl compounds. Now you see the basic reaction, like for example acetone. If I take acetone, when you are adding the HCN, in which one side H, one side cyanide, the H goes to the O. So therefore O will become OH and the entire cyanide is added to the carbon. So the product formed like this. This is the final product. So HCN added products are called cyanohydrin. This, if I call it as a acetone. So the answer, you call it as a cyanohydrin of acetone. Cyanohydrin of acetone. Corresponding cyanohydrin is formed. This reaction is also, there is a double bond, something is added, the double bond has become single bond. Therefore, this is an addition reaction, in which now only the difference between the previous reaction is that was a CC double bond, this is a CO double bond. So this makes the fundamental difference. When C double bond O is there, before whether you add the reagent or not, this acetone is liable to undergo open up and become into the plus and minus. So this exists in the equilibrium, or a polarized and unpolarized system, and the polarized system will be in equilibrium. So sometimes it will be with bond closed one, sometimes it is open bond. So many times C plus and O minus will be readily available, even though when HCl is not added also it will be available. A part of the carbonyl compound will exist in the form of the cation and the anion. Now out of the C plus and O minus, if you compare, O has got the two lone pairs and a minus charge and this one, so 8 electrons are there, whereas this carbon 6 electrons are there. So 6 electrons are shows that 2 electrons less to the octet, therefore this there is than the carbon there is one problem is there. Whereas oxygen acquired 8 electrons, that is called octet rule. According to the octet rule, 8 electrons whenever an element achieves there gets some stability. So with reference to the stability, if you discuss, the C plus has got some, the instability is there. And another one, the carbon also, if you take the periodic table, both the carbon and oxygen both are electronegative only, and the right side upper will be there. An electronegative element, if it becomes negative, it is happy, that means stabilized. But this carbon is also electronegative, but it has become a positive, therefore it is destabilized or more reactive. So electronegative with positive charge. So these two reasons, one with this electron, 6 electron, that is 2 electrons are less to the octet. Another reason, electronegative element with positive charge. These 2 points makes the carbon to have a less stability and more reactivity. So that means when you take the both C plus and O minus, C plus is more reactive than O minus. Though when you add H plus and Cl minus simultaneously, the cyanide minus is allowed first because the C plus is more reactive. It is more reactive first cyanide minus. So, therefore, step 1 happens to be nucleophile. It is not the greatness of cyanide. It is the from the compound side, it is allowing the cyanide first because the C plus is more reactive than O minus. So, first cyanide attacks, then what happens? The carbon gets a cyanide, oxygen will become minus charge and the two methyls will be as it is. There is no participation of these two groups. Now, the H plus is added. That is step 2. Step 1, step 2 is the electrophile. Always step 2 second steps will not have any much significance. Step 1 will make the reactivity or increasing, decreasing, fastness, all that kinetics approach and all that they depend on the step 1. So, therefore, the moment cyanide attacks followed by the H plus takes place, the completion of the reaction. So, what is the intermediate also? In this intermediate, the charge is not on the carbon. It is on the O minus. O is electronegative and there is a minus charge, therefore, comfortably it is stable. There is no much importance for the carbon. This is the intermediate also. Previously, we had a carbocation in the electrophilic. That is very important because carbocations, depending upon the stability which is formed or the migration of the carbocation leads to the rearrangements or cyclizations and so on. Several types of the discussions are attached to that. Here, there is no much the discussion. So, nucleophile first attacks followed by the electrophile, the product is formed. The only important is here, this is also a double bond like CC double bond. Why this is not undergoing electrophilic addition? The first reason is it will be opening and like this plus minus structure always will be there. In this plus minus, that is C plus is more reactive and less stability because of these two reasons. That is why first nucleophile attacks, whichever the nucleophile that attacks and then reaction. Now, here the basically how best the C plus is stable. If we have a groups like methyl groups, it shows inductive effect. So, stabilizes, rate of reaction decreases. If a phenyl is the resonance, rate of reaction decreases. If hydrogen sulfide, hyperconjugation, rate of reaction decreases. Big groups of steric hindrance, rate of reaction decreases. So, we have different types of the issues attached to this stability of the carbocation. More the stable, less will be the reaction. It is starting material, not the intermediate. Intermediate, if it is stable, reaction takes place. More the intermediate is formed, then reaction. This is stable means it is starting material. The carbocation and these two are nothing but the equivalent, isn't it? So, the more the stable the starting material, rate of reaction will be less. Therefore, more stabilizing groups which are stabilizes the carbocation will have a rate of reaction decrease. Therefore, you can say without any groups means formaldehyde is the first compound. So, the formaldehyde happens to be the most reactive carbonyl compound toward this nucleophilic addition, and when compared with all the more the groups, complicated groups will rate of reaction decreases, right. So, this is what a nucleophilic addition reaction, the complications will take later.